Okay, in this lesson we're going to talk about simplifying powers and roots. And to do this we're going to be using a table of powers chart here. So in the first example we want to evaluate what 6 to the 4th is. And so the base is 6 and we go over to n to the 4th. This is the 4th power right here. So 6 to the 4th power would be 1,296. And next we'll do 12 to the 3rd, and so 12 is the base, and we want to go over to the 3rd power, which would be, this is the 3rd power, 1,728. And we'll do one more, 15 to the 3rd, so 15 to the 3rd power would be 3,375. Now we can also use this table of powers to find square roots. So when we're looking at the number, the square root of 196, we're really asking what number squared gives me 196? Now when you don't see a number here, it means square root. So we're looking at the numbers squared, which is this column right here. So to do that, we look at 196, here it is right here, and what number squared gave us 196? Well, it was 14 to the 2nd power. And in the next problem, again, it's the square root of 361. So we'll go down to 361 in this column, and what number squared is 361? It was 19. And again, square root of 256. Look at the list of n squared. 256, what number squared is 256? It would be 16 squared. So 16 is the square root of 256. Now we also have a cubed root here. And when it says the cubed root, it's saying what number cubed would be 1,728. So we want to look at what the numbers are that are cubed. So if you take a number that's cubed and we get 1728, here it is, okay, and then we follow the chart over and find that 12 to the 3rd power would be 1728. So the cubed root is 12. Let's look at the cubed root of 343. So we'll look at the list of cubes. 343 is a perfect cube. What number cube gives us 343? Well, it's 7. And in this next problem, it tells us to evaluate the 5th root of 3,125. So now we're looking at numbers taken to the 5th power, which is here, and 3,125 is here. And what number to the 5th power gives us that? Go over, it would be a base of 5. So 5 to the 5th power is 3,125. So the 5th root of 3,125 is 5. And just one more. This is a 4th root. So we're looking at numbers to the 4th power. They give us 2,401. So we'll look at the 4th powers here, 2,401. Here it is. And we go over to see what the base is. That's 7. 7 to the 4th is 2,401. Now we're going to talk about how we simplify powers. Now if you look at your chart, if we want to take the square root of 50 and look at the list of perfect squares here, 50 is not on that list. But in order to simplify it, we also have a rule that says that we can't have any perfect square factors inside of the radical. Well, 50 breaks down to 25 times 2. And if you look at our list of squares, 25 is on that list. So we write it down. And using the property that the square root of a times b equals the square root of a times the square root of b, we take the square root of each of those, and then we can evaluate. The square root of 25 is 5. So instead of writing root 25, we just write plain old 5 and then times the root 2. So now when we're looking at the square root of 12, well, 12 is not on that list. It's not a perfect square. And so we want to look and see, are any factors of 12 on that list? Well, 4 is a factor of 12. So we would write 12 as 4 times 3. And then we can break it apart into the square root of 4 times the square root of 3. And that would be 2 square root of 3, because the square root of 4 is a 2. Here's another example, the square root of 32. So we look at the list of perfect squares, And we want to start kind of from the bottom and work our way up. What goes into 32? Well, 16 does. 4 also does, but it works the easiest if you take the largest perfect square factor. So 16 times 2 is the square root of 32. Well, at this point, you can take the square root of 16, which is 4, and then the square root of 2 is not a perfect square, so that just stays as the square root of 2. So the simplified answer is 4 root 2. Now, let's say that you would have been looking at the list for the square root of 32, and you chose 4 instead, because 4 is a perfect square. Well, that would be 4 times 8, and then the square root of 4 is a 2, so we would write 2 times the square root of 8. However, you would not be done yet, because the square root of 8 has a factor of 4, or 8 has a factor of 4, so you would have to break that up again to 4 times 2, and then you have 2, and the square root of 4 is 2, and then you still have a root 2 left inside. So we need to take the square root of that 4, which was a 2, which would be 4 times the square root of 2 for my final answer. And they're the same, but the second one, when I didn't take the largest square root factor, I had to do the process twice. And now let's look at simplifying larger roots. So like we have the third cubed root of 24. This time we're looking for perfect cube factors. So we have to be looking at this list, the list of perfect cubes. So we look at this listing and we say, what goes into 24? Well, 8 does. So we're going to write this as the cubed root. Oops, my pen is struggling here. 8 times 3 is equal to 24. And remember, using the property from before, we break that into the cube root of 8 times the cube root of 3. And we can evaluate, what is the cube root of 8? Well, if we look on our chart, 8 is a perfect cube, and that would be 2 to the third power. So the cube root of 8 is 2, and then times the cube root of 3. Here is another example. The cube root will go down to the cube root of 192. And we might need to take our calculator and start dividing numbers and figure out what goes into 192. I believe it's 64. 64 times 3. Yep, that would be 192. So we'll write 64 times 3. That equals 192. And then if we take the cube root of 64 times the cube root of 3, and now we evaluate what's the cube root of 64? Oh, it's 4. So we have 4 times the cube root of 3 for our simplified answer. Now let's talk about adding and subtracting radicals. That is very similar to adding and subtracting like terms. So when the variables are the same, you actually add the coefficients, the numbers in front. So 2x plus 3x is 5x. Here's another example. If we wanted to simplify this, well, there aren't any other x squared terms, so we just write 4x squared terms, but 5x and 2x are like terms, so we combine those. So when we add radicals using that same concept, 3 times square root of 5 plus 2 square root of 5, when their square root of 5s are the same, you add the numbers in the front. So you would have 5 times the square root of 5. Here's another example, 2 root 2 minus 3 root 2. The root 2's are the same, so we take 2 minus 3. You get negative 1 root 2, or you could just write negative root 2. Here's another example. We have 3 root 5 minus 6 root 5 plus 2 root 6. Well, only a couple of them have the same root, 3 root 5 minus 6 root 5, so those we can combine. And then we just write plus 2 root 6. All right. Here's another example. As we look at this, we have a root 5 and a root 45, and hopefully you're saying, well, you can't add those, they're not the same. However, we always want to make sure that we've simplified the roots. And the square root of 45 can be simplified. So we would write that as negative 2 root 5 minus 2 times the square root of, and we want to look at our chart again at our perfect squares here. 9 is a perfect square, so 45 would be written as 9 times 5. Now at this point, we can take the square root of 9 and the square root of 5. What is the square root of 9? It's 3, so I'm going to put that out front, and that's a factor, so it gets multiplied. And so let's rewrite this. And what we end up with is negative 8 root 5. That is my simplified answer. And here's one more we can do for practice. Again, right now the roots aren't the same. So we'll write negative 3. And then 9 goes into 54 6 times. So we'd write 9 times 6 minus 3 times the square root of 4 times 6. So the square root of 9 is 3. So this is negative 3's out there. We also then have to bring out a positive 3. And the square root of 4 is a 2. So I have to fit that in here, times 2. I'm going to write small. Sorry about that. So now we have negative 9 root 6 minus 3 times 2 is 6 root 6. And then, so now we can combine these because they're both root 6. So minus 9 and minus 6 is minus 15 root 6. There's your final answer.